Casting. Casting is a manufacturing process which allows materials in a molten state to turn into complex parts. The process of casting initially requires us to get our desired material into a liquid form. To do so, let's say we're talking about metal. To get metal into a liquid form, we have to heat it up to get it into a molten state. Afterwards, we have to pour it into a mold of a desired shape. To get our liquid material in a solid form, we have to cool it. Our cooled material then is what we call our casting. To get the casting out of its mold, we have to either eject it or break it out of the mold. There are two main types of castings that I'm going to talk about in this video. It's metalworking and resin casting. Metalworking, as the name says, focuses on using metals. Resin casting, on the other hand, focuses on using plasters, concrete, and plastic resin. Casting as a manufacturing process is most often used for mass production. It allows for rapid and economic manufacturing of complex parts compared to cutting or forming and shaping.
Forming processes are manufacturing processes which make use of suitable stresses like compression, tension, shear, or combined stresses, which cause plastic deformation of the materials to produce required shapes. The most frequently used material is metal, followed by plastic or glass. Forming does not add or remove material, only changes its shape. Forging uses compressive blows to shape material when it's either hot or cold. This can be done slowly by hand or quickly and on larger scales using a power hammer. Forging is not very precise, but inexpensive and quick. Extrusion is the process of forcing a heated material, usually glass or metal, through a die mold to attain a specific cross-sectional shape, which can be very precise and have a high-grade surface finish. Rolling is when a metal is forced between one or more pairs of rollers to reduce thickness, which can be done at high and low temperatures. This is an inexpensive and quick process. Sheet metal forming is when stresses are applied to sheet metal to change its shape, sometimes when rotating or just pressing, and is used often in conjunction with rolling. Shaping or planing is a material removal in which the workpiece reciprocates against a stationary cutting tool, producing a plane or sculpted surface like a groove. In shaping, the tool is brought into position with the workpiece and then repeatedly moves in a straight line while the workpiece is incrementally fed into the line of motion of the tool. This then produces a flat, smooth, and sculpted surface. Machining is the broad class of operations on raw materials to remove material to achieve a desired shape. This is known as subtractive manufacturing. These materials are most frequently metal, but can also include wood, plastics, and ceramics. Today, these processes are usually carried out by a computer numerically controlled machine, also known as a CNC machine. These are automated mills or lathes that have many axes. Material is cut when a tool which is harder than the material has a high amount of relative motion. This motion is achieved by primary motion, called cutting speed, showed as N, and secondary motion, called feed, showed as F. The three main operations of machines are turning, where the material is rotating and the cutting tool feeds, drilling, where the cutting tool is rotating and the material is stationary, and milling, when the cutting tool is rotating at cutting speed and the material or tool is moved relative to each other. The tools range anywhere from standard end mills to complex gear grinding wheels. Many times, a lubrication solution is used to reduce stress from heat between the tool and the part to increase the longevity of the tools. One other machining operation that is slightly different is surface grinding. This is where a part is moved on a flat table relative to a large spinning disc to achieve a desired surface finish. Drilling, milling, and turning are all relatively inexpensive as long as the tolerances are not very precise. Reaming is re-drilling a hole to a slightly larger size for a precise fit and is more expensive. And operations like this one on a multi-axis machine are far more expensive than their three-axis counterparts.
Joining attaches two parts using various methods such as fasteners, adhesives, and welding. Welding is usually used to join metals or thermoplastics. The material being joined is melted and a filler material is added to create a pool of molten material that cures into a solid joint. Gases such as argon, helium, and carbon dioxide are commonly used to protect the weld from contamination and oxidation. Flames, electric arcs, lasers, and friction and ultrasound are used to melt the metal. Brazing is similar to welding, except only the filler material is melted. Adhesives can also be used to join parts together. Adhesives can be used to join many different materials. First, the surfaces of the parts must be cleaned in order to ensure a solid bond. Next, the adhesive is applied and the parts are put together. Finally, the adhesive is cured using heat, light, pressure, and time. Another way to join parts together is using fasteners such as screws, nails, nuts, bolts, rivets, and staples. These fasteners can be removed without damaging the parts, unlike welding and adhesive bonding. For some fasteners, like bolts, a small amount of tolerance needs to be allowed in order to insert the fasteners. Fasteners and adhesive bonding are cheap, however welding requires expensive machinery and skilled workers, so it is more expensive. Fasteners can normally be installed quickly. Welding can be more time consuming due to prep work and the number of welds. Adhesives may need more time to cure.
The manufacturing process finishing is a range of different processes that change the surface of the product to achieve a certain property. There are four main different types of finishing. They are honing, laping, deburring, and polishing. The honing process is performed by a honing tool, which contains a set of 3 or more bonded abrasive sticks along the outside of the tool. They are held against the work surface with controlled light pressure, usually exercised by small springs. The honing tool is given a complex motion to produce a cross-hatched lay pattern of very low surface roughness. Laping is a machining process in which 2 surfaces are rubbed together with an abrasive between them, by hand movement or using a machine. The most obvious difference between laping and the other major machining operations is laping doesn't use a single or multiple point cutting tool. Laping cuts chips by way of a loose abrasive process. The tool uses this process using a lape, which is usually made out of a soft material like copper, lead, or wood. Deburring is to simply remove the burrs that came from the manufacturing process. The term burr refers to a rough edge or ridge left on an object by the action of a tool or machine. This affects the quality of the part and can create potential sources of error during the assembly process. Polishing is a finishing operation to improve the surface by using a polishing wheel which rotates at a high speed. These techniques are usually done by hand. The wheels that are used for this process are usually made out of linen or cotton.